Okay, here are some more problems from section 5.1, and this is number 36. And on the left, we have cosecant x minus secant x all over cosecant x plus secant x, and we want to show that that equals cotangent of x minus 1 over cotangent of x plus 1. So again, look at the structure of what you've got, and this kind of helps guide you in what you need to do. And I notice here what I have is I've got a fraction, that's nice. Two terms in the top with a minus sign, or a difference in the top, and a sum in the bottom. So that's nice. So I've got a lot of the structure already set up. So if I want to make this look like this, here I have a 1. I should say 1's here and 1's here, so I need to make these 1's. And I can do that easy enough by dividing by secant. Okay? So what I'll do is I'll divide everything by the secant and make these the 1's, and hopefully this will work out. Okay? So on the top I've got the c as cosecant of x minus the secant of x. And on the bottom I've got the cosecant of x plus the secant of x. And I'm dividing the top and the bottom. It's like multiplying by 1 over the secant. So I'm going to divide every term. Now that's like multiplying the top and the bottom by 1 over the secant of x. And 1 over the secant of x all over 1 over the secant of x is 1. So it's pretty much like doing that. It's like multiplying the top and the bottom. I'll do it over here. 1 over the secant of x all over 1 over the secant of x. All right? So it's like I'm multiplying the top and the bottom by this, and this is the same thing as 1, right? That's the top, the numerator, and the denominator are the same. So if I multiply this by 1 over the secant of x, I have a secant of x in the bottom. And then I have to multiply the bottom also by that, because I'm multiplying by 1 or this over that. Okay? So it's all balanced out. So everything's legal algebraically. Now what does that achieve? Well, that gives me my 1's. All right? Now I can also simplify these while I'm at it, but this is going to be negative 1, so I can take a look at this over here. And that's going to be negative 1, and that's going to be positive 1. So you see now how this begins to look like that. So this was the motivation. This is what motivated me to get these 1's here. So I've got that, but now I'm left with this over here. So what's going to happen with this? Well, okay, what we can do is we can try to, well, these are both the same, so that's nice. I could probably simplify these off on the side and see what I've got. But I'll just do it in the same order. So this is going to, what's the secant? The cosecant is the same. Oh, these are reciprocals, aren't they? Jeez. There's lots of ways to do this, okay? I'll just do it, and I'll put everything in terms of sine and cosine because that's a little bit easier for me. But if you want to do it a different way, that's up to you. Okay, so what I'll do is I'll write this as, this is going to be 1 over the sine all over 1 over the cosine. Is that all right? So that's a little bit easier for me to think of it like that. I put everything in terms of sine and cosine. And the bottom's the same thing, isn't it? It's exactly the same thing. So 1 over the sine all over 1 over the cosine. Now remember, if we take something like this, we would invert and multiply, right? And I could do that over on the side if you wanted to see this done. I could take, I'll do it over here. This would be 1 over the sine of x times, and we would invert and multiply, cosine of x over 1. And when we do that, what do we get? We get the cosine over the sine. So I'll rewrite this now as the cosine of x over the sine of x, and that's in the top, minus 1. And on the bottom, I've got that cosine of x over sine of x. So that's from over here, and that was from over here. Okay, so in other words, we can multiply the top and the bottom by the LCD, but sometimes it's easier to do it the more traditional way, where we take the top fraction divided by the bottom fraction. That's the other way to simplify complex fractions. We've got two ways. This is the other way. Okay? And then once we see this, and we just multiply numerator times numerator, you have cosine over sine. But what is the cosine over sine? Cosine over sine is the cotangent. So I've got the cotangent of x on the top and the bottom. So that's a cotangent of x, and this is minus 1. And that's a cotangent of x, and this is plus 1. And it looks like that's what I wanted to prove. All right? So we can put don't know, don't know, don't know, and now I do know. Checked. Okay? And I could just ditto these, you can bring these back down. It's the same thing. Ditto, ditto. Okay, like that. So this is the same thing. I just don't have to write it all the time. So it stays the same on the right, and I'm just going to make the left look like the right, okay? And let me just frame that for you, okay? So that's basically how you do it. It's not that bad. I hope you understand the motivation. The idea is, why did I do what I did? Well, again, like I said, I wanted to get the ones. I see these ones. I can make those ones by using this technique. Okay? Hope you understand that. Think about it. Try to get the style of these things, how we are putting these facts together. And again, these are just kind of like little puzzles, little proofs. Okay, number 39. And number 39 is the tangent squared of 2x plus the sine squared of 2x plus the cosine squared of 2x. And we want to show that that equals the secant squared of 2x. Now 2x, it's just an angle, so we could call it x if we wanted, or theta. It's one particular angle. They're all the same, so that makes it nice. And remember, what is this? That's our good old friend, isn't it? That's our Pythagorean identity. It's even if it's 2x, 3x, 4x, as long as these are the same, the sine squared of something plus the cosine squared of something is always equal to 1. So now I've got the tangent squared of 2x plus 1. Now this is a question mark here, but this is our identity. This is our basic identity. If we go back here and we talked about that in I'll bring it back here in number 33. I wrote it right there. 1 plus the tangent squared equals the secant squared. All right? That was one of our Pythagorean identities, which is easy enough to derive from this if you don't remember it. So that definitely equals the secant squared of 2x. So that's a check right there. So that was a nice one. Nice and easy. Okay? So that worked out. And I think the intent was to make sure that you remember those other forms of the identity. And it's 1 plus the tangent squared of x equals the secant squared of x, and then 1 plus the cotangent squared of x equals cosecant squared of x. So those are the other two Pythagorean identities. And I usually always just, because you've got these over here, if I don't use them enough, I just can always derive them by dividing and showing you how. I've showed you how to divide by either the sine squared or the cosine squared, and you can derive either one of those. Okay? All right, I hope those help.